is to solve systems by elimination. That's also called linear combinations. You don't have to take any notes yet, okay? Because you already have notes on this from before break. So here's an example. I'm going to call it example A. I'm not numbering it because you don't need to write it down. So this is a system, and we can solve this by elimination because we have opposite terms. See how we have minus 4y and plus 4y? Well, what we can do is we can just add these two together, because when we add these two together, what's going to happen is this is going to make negative 7x. These terms will cancel, and then this makes negative 7. So what's happened is we've eliminated the variable y because we have opposite terms. Okay, that's the key to the elimination method, is having opposite terms. It won't always be y. It won't always be the number 4. But you have to have the same letter, same number. One term's positive, one term's negative, because then they cancel out. So we can proceed to solve this equation for x. And then to find y, we're going to plug in either to the top equation or bottom. It does not matter which one you use. I plugged into the bottom equation because the numbers were a little smaller. So I just plugged 1 in for x, and then we solve for y. And then we write the ordered pair as our final answer. You don't need to copy that down because, like I said, you already have a couple of these in your notes from December 22nd or December 23rd. Okay, one more review example before I hit you with something new. Here's example B. You don't need to write this one. This one is not set up with opposite terms. That's what's different here. So I've labeled this as equation 1, equation 2, and we don't have opposite terms, okay? Because if we add these, it makes 3x, and if we add these, it makes 7x. Neither of those cancel. So what we learned last time before the break is that we can create opposite terms. So we want to look at x's and we want to look at y's and see if we can multiply by something to get the numbers to match or to be opposites. So looking at 6 and 3, I think we know that if we multiply this by 2, we're going to end up with negative 6x. So that's the goal for this one. The goal for this one is to get positive 6x and negative 6x, which I probably wrote down. Yeah, I already wrote it down. Okay, I wrote it down twice. The y's won't work easily here because there's nothing I can multiply 4 by to turn it into 3. And there's nothing I can multiply 3 by to turn it into 4. Okay, so that's why I focused in on the x's, because if I just times this by 2, I have the negative 6x. I have the opposite term that I wanted. So what I'm going to do is I'm going to take the equation 2. See, I copied it, and I multiply both sides by 2. When I do that, I have to distribute, and I end up with what I call new equation 2. That's just what I call it. So what we're going to do next is we're going to take equation 1 and new equation 2 and add them together because they're going to have the opposite terms that we wanted. So I copied equation 1. Here's my new equation 2. And if you check it out, what's going to happen here is 6x and negative 6x are going to cancel. So the x is going to go away, and that leaves us with just the variable y, and we can now solve to get y equals 3. Once you have y equals 3, you can plug into equation 1, equation 2, or new equation 2, but those numbers are bigger, so I avoid that one. All right, so what did I think I probably chose this one. Oh, I chose this one. I couldn't remember. All right, so I plugged in 3 for y, because it doesn't matter which one you pick. You can plug in either one. Your work will be different, but you should get the same answer as me at the end, regardless of which one of those you might choose. So there's my x and my y ordered pair. All right, so that's a little quick review of the topic. Now please take notes. We're going to do 2 more examples. Okay, so we're going to call this example 1. Write today's date on the notes. This is section 4.3 in the textbook. And copy down the directions and copy down the problem. Now, here's what's very different about this one. We cannot multiply to turn 3 into 4 or 4 into 3, not easily anyway. It would involve some crazy fractions. And we can't multiply 5 to turn it into 2 or 2 to turn it into 5. It would involve crazy fractions. So what we need to do to get our opposite terms is we need to use the least common multiple of these coefficients. And you're going to have some options here. So what you can do is you want to look at 3 and 4. Let's start there. There's nothing easy that you can times this by to turn it into 4. There's nothing easy you can times this by to turn it into 3. But you have the power to change both of them. So what's the least common multiple of 3 and 4? Well, that's 12. So what you can do is you can try to get negative 12x and positive 12x. So you can't turn these into each other, but you can turn that into negative 12 by multiplying by 4, the whole thing. And you can turn this into positive 12 by multiplying the whole thing by 3. So that's one option for you. Another option that you have is to multiply and try to get these to be opposite terms. Now, if you want these to be opposite terms, you're not going to be able to make 12s. So you want to think you have 5 and you have 2. What's the least common multiple of 5 and 2? That's 10. So another option is to aim for 10y and negative 10y. Okay? So you either want to try to change these guys into negative 12x and positive 12x, or change these guys into 10y and negative 10y. It's up to you which one you want to do. I'm going to do this one because I think I'd rather multiply by 2. That sounds pretty easy. And multiply by 5. That sounds okay. All right, multiplying by 4 and multiplying by 3 would totally also work. So let's grab equation 1. And you know what? I'm going to organize this work a little differently. I'm going to just copy this down here. When I multiply both equations by something, I organize a little differently to save myself some writing. So we said we're going to aim for 10y and negative 10y. To make 10y happen here, I'm going to multiply both sides by 2. And what I'm going to do just to save space is I'm just going to go ahead and put that right next door. So instead of like recopying and recopying and recopying, I'm just going to put that next door. So that's going to give me negative 6x plus 10y equals negative 34. And remember, the goal here is 10y and negative 10y. So for this one, I'm going to multiply both sides by 5. And again, instead of like writing it underneath, because then I'll have to recopy it and label everything, I'm just going to write this right next door. So if we distribute the 5, we get 20x minus 10y equals 18 times 5. That's pretty big. I probably wouldn't give you one quite that big in a homework or anything, but we can handle that in class. All right, and this would be my new equation 1 and new equation 2. But since I already have them lined up, I don't have to like take the time to label all that. All right, so let's add these up. This is 14x. These cancel. That's the whole reason we wanted opposite terms. That's why we aimed for 10y and negative 10y. And then these over here, let's see. I have to subtract them. And since I have a negative 34 plus 90, I'm going to get a positive 56 there. That sounds good. And then what we need to do is we need to divide both sides by 14. Now, I don't think I'd normally look at 56 and know that 14 goes into it, but I've worked this problem out previously, so I can tell you that it goes into it 4 times. All right, so if we were to do that multiplication, it goes in 4 times. The way I figured that out the first time, actually, is I reduced. I reduced this by 2, and I reduced this by 2. And then I said, oh, yeah, 28 over 7 is 4. Okay, so now that we have the x, we just need to find y. You can choose any of the equations that you want to use. I'm going to go ahead and use this one because it has fewer negatives. But you could use either equation. Your work would look different, but you'd get the same answer that I'm going to get. All right, so I'm going to plug in 4 for x. I get 16 minus 2y equals 18. And then I divide both sides by negative 2. And I get y equals negative 1. And my final answer then is xy, the ordered pair. Oops, you couldn't see that. My final answer is xy, the ordered pair, for negative 1. All right, let's take a look at one more problem, but we won't solve it the whole way, okay? And again, just to remind you, this was one option. We totally could have multiplied the top one by 4 and the bottom one by 3 and canceled these instead. All the work would be different, but you would end up with the same answer at the end if you did it correctly. Okay, so taking a look at this one, once again, it's not easy to multiply and turn 3 into 2 or 2 into 3. It's not easy to multiply 5 and turn into 6 or turn 6 into 5. We'd have to do some crazy fractions. So what we want to do instead is we want to multiply both equations and change these into opposites. So the key to that is to look at the least common multiple. Let's focus on the x's right now. The least common multiple of 2 and 3 is 6. So if we can make a 6x and a negative 6x, we'd be good to go. We would have opposite terms. Can you turn this into 6x? What would you multiply by? You would multiply both sides by 2. Can you turn this into negative 6x? Sure, what would you multiply by? You multiply both sides by negative 3. And that would lead you to a correct answer. Now, just to give you another option, you could change the y's. Since we have 5y and 6y, you would aim for 30y and negative 30y. But those numbers are a lot bigger. So I'm going to try to cancel the x's instead. Okay. So what I would do here is copy the originals. And again, I kind of alter my style on this when I have to multiply both equations, because otherwise I have to do a lot of rewriting and labeling. So as long as I keep in mind that my goal is to get 6x and negative 6x, what I can do is take the top equation and multiply both sides by 2. And then what I like to do is right next door, show my new equation. I got the 6x, so I need the negative 6x. So the bottom equation, I'm going to multiply both sides by negative 3. And right next door, I'm going to go ahead and distribute here. And I get 12. Okay. So now that I have my opposite terms, I can go ahead and add these up. This becomes 0. It cancels. I get negative 8y equals 0. That's kind of weird. That doesn't happen too often, but it certainly does happen. Okay. So this makes 0. 0 is a number. That's okay. And when we divide both sides by negative 8, we get y equals 0. And then we need to plug into an equation to solve. We can plug into the top or the bottom. Doesn't matter. I'm going to plug into the top one. I don't know why. I just felt like it. It wouldn't matter. We'd have different work, but we'd get the same answer in the end. So if I plug in 0 here for y, 5 times 0 is 0, so that goes away. And then when I divide both sides by 3, I get x equals negative 2. So my final answer is negative 2, 0. All right. And that's not the only way to solve this problem. We could have multiplied the top by 6 to make 30y, multiplied the bottom by negative 5 to make negative 30y. All of our work would look different, but we'd get the same answer at the end. Another option, just in case you thought of it, I changed the top to 6x and the bottom to negative 6x. If anyone out there was thinking, could you have times by negative 2 to make this one negative and times by 3 and make this one the positive? Absolutely. Your work would look different, but your answer would be the same. All right. And I don't want to bore you by showing you 4 different ways. So I picked this one way to show you, but I want to take a moment to acknowledge that there are different ways to solve it.